Okay, video is for the Brilliant Deduction in-lab problem. If you missed the Brilliant Deduction lab or you just want to know how a problem like that is done, you should watch this video. There will be a problem like this on the test. Alright, so the whole idea of this in-lab problem is to find the simplest whole number mole ratio between iron and oxygen. Okay, we're going to heat them up, and the iron is going to combine with the oxygen, and it's going to make some formula over here. But we don't know what the ratio of Fe to O are. But if we could find the moles of each, we'll be able to figure out the ratio. So the first thing is we can mass the empty crucible, then we're going to put some iron in it, and before heating, we mass it. And by taking the difference between the two, we can find the mass of just the iron. So that's supposed to be a 5. So if we take that and we minus 20.000, we get 2.250 grams. Okay, that's the mass of iron. Then after we heat it, the iron combines with oxygen, and the contents of the crucible gains mass, because in the crucible, to begin with, we just have we have some iron, but after heating it, the crucible has iron and oxygen in it both. That's why it's going to gain mass. So if we take this 23.218 and we subtract, now this is where we have to be careful, because we just want the mass of the oxygen. So what we have to do is we have to take 23.218, and that's the mass of the iron and the oxygen. And if we want the mass of just the oxygen, we have to take the empty crucible and the iron away from it. A lot of people make a mistake right there, and they subtract the empty crucible, but what that gives them is just the mass of it gives them the mass of the iron and oxygen, but we want just the mass of the oxygen. So we got to take the crucible, iron, and oxygen minus the mass of the crucible and iron to get the oxygen. And so the oxygen is 0.968 grams. Okay? Now, it's just a matter of converting both to moles, and then we'll be able to figure out the mole ratio. So we're going to take the iron, which is 2.250 grams of iron. We're going to change it to moles. So 1 mole iron, you look up the molar mass of iron, it's 55, roughly 0.8 grams. And if you do the moles of that, it's 0.04032. Okay, then I'm going to do the same thing with oxygen. So I got 0.968 grams of oxygen. Now it's not oxygen gas, it's oxygen in a compound. So it's not O2, it's just O. Whenever it's like oxygen gas, like by itself out in the atmosphere or whatever, then you can call it O2. But this is not oxygen gas, it's oxygen in a formula, so it's just O. And we have to change that to moles, so 1 mole oxygen equals roughly 16 grams oxygen. And if we change that to moles, we get 0.0605. Okay, this is the moles of iron, this is the moles of oxygen. Now, what we're trying to find is the simplest whole number ratio of iron, which is Fe, to oxygen. We're trying to find what these numbers are in the formula. So we have to take these mole ratios, because this is in the simplest whole number mole ratio. So we have to take these numbers and put them and figure out what the simplest whole number ratio is. The way that you do that is you take the smaller number of moles, which is the 0.04, the iron, and you divide it by itself. And when you divide it by itself, that equals 1. You take the bigger amount of the moles and you divide it by the smaller amount, and you're going to get roughly 1.5. Okay, so now the ratio is 1 Fe mole to 1.5 oxygen moles, but it has to be in the simplest whole number ratio. So if you're not in the simplest whole number ratio, you just need to, in this case, it's 1 to 1.5. If you just multiply everything times 2, then you can get rid of your fraction or decimal there. So it's Fe2O3. That is the simplest whole number decimal form. Okay, now, or not decimal, the simplest whole number mole ratio. Now, the biggest mistake that people make in this whole lab thing is finding the mass of the oxygen. You have to take the mass of the iron and oxygen, that's this number right there, subtract the mass of the crucible and the iron. Okay, not the empty crucible, because then that would give you the mass of FeO, which we don't want that. We just want the mass of oxygen. Okay, that's how I got the grams of oxygen right there. All right, that's it.